A space telescope or space observatory is a telescope in outer space used to observe astronomical objects. Why do we need space telescopes? The traditional telescopes can be used to view objects in space which are relatively nearer to Earth. But the objects which are far from Earth require bigger sensors and lenses to capture all the 𝕤𝕚𝕓𝕐𝕗 details. These 𝕤𝕚𝕓𝕐𝕗 details reside in the non-visible spectrum of light. Thus, the main reason we put telescopes into space is to get around the Earth's atmosphere so that we can get a clearer view of the planets, stars, and galaxies that we are studying. Our atmosphere acts like a protective blanket, letting only some light through while blocking others. Most of the time, this is a good thing. No level of SPF could protect us if we were bombarded by high-energy X-rays or gamma rays whenever we went outside. But that protection means we are out of luck when it comes to collecting those forms of light for ground-based studies. We can't exactly ask the atmosphere to make any special exceptions for light we would hope to reach our telescopes. Now, let's talk about the first fully functional telescope. The Hubble Space Telescope, often referred to as HST or Hubble, is a space telescope that was launched into low Earth orbit in 1990 and remains in operation. Hubble features a 2.4M mirror, and its 5 main instruments observe in the ultraviolet, visible, and near-infrared regions of the electromagnetic spectrum. Hubble's orbit outside the distortion of Earth's atmosphere allows it to capture extremely high-resolution images with substantially lower background light than ground-based telescopes. It has recorded some of the most detailed visible light images, allowing a deep view into space. Space telescopes were proposed as early as 1923, and the Hubble telescope was funded and built in the 1970s by the United States Space Agency NASA with contributions from the European Space Agency. Its intended launch was in 1983, but the project was beset by technical delays, budget problems, and the 1986 Challenger disaster. Hubble was finally launched in 1990, but its main mirror had been ground incorrectly, resulting in spherical aberration that compromised the telescope's capabilities. The optics were corrected to their intended quality by a servicing mission in 1993. Hubble is the only telescope designed to be maintained in space by astronauts. 5 space shuttle missions have repaired, upgraded, and replaced systems on the telescope, including all 5 of the main instruments. The 5th mission was initially cancelled on safety grounds following the Columbia disaster, 2003, but after NASA Administrator Michael D. Griffin approved it, the servicing mission was completed in 2009. Hubble completed 30 years of operation in April 2020 and is predicted to last until 2030 to 2040. The James Webb Space Telescope is a space telescope currently conducting infrared astronomy. As the largest optical telescope in space, it is equipped with high-resolution and high-sensitivity instruments, allowing it to view objects too old, distant, or faint for the Hubble Space Telescope. This enables investigations across many fields of astronomy and cosmology, such as observation of the first stars, the formation of the first galaxies, and detailed atmospheric characterization of potentially habitable exoplanets. Webb's primary mirror consists of 18 hexagonal mirror segments made of gold-plated beryllium, which combined create a 6.5-meter diameter mirror, compared with Hubble's 2.4M. This gives Webb a light collecting area of about 25 square meters, about 6 times that of Hubble. Unlike Hubble, which observes in the near ultraviolet and visible and near infrared spectra, Webb observes a lower frequency range, from long wavelength visible light, red, through mid-infrared. The telescope must be kept extremely cold, below 50 K, such that the infrared light emitted by the telescope itself does not interfere with the collected light. It is deployed in a solar orbit near the Sun, Earth L2 Lagrange point, about 1.5 million kilometers from Earth, where its 5-layer sunshield protects it from warming by the Sun, Earth, and Moon. The James Webb Space Telescope has 4 key goals: to search for light from the first stars and galaxies that formed in the universe after the Big Bang, to study galaxy formation and evolution, to understand star formation and planet formation, to study planetary systems and the origins of life. These goals can be accomplished more effectively by observation in near-infrared light rather than light in a visible part of the spectrum. For this reason, Webb's instruments will not measure visible or ultraviolet light like the Hubble telescope, but will have a much greater capacity to perform infrared astronomy.